Hi, this is Halal. In this video on Mathematical Economics series, we will solve a numerical on the applications of input-output analysis. In economics, we have a numerical. The question is, in an economy, there are two industries, I1 and I2, and following table gives supply and demand positions in million of dollars. We are given the two industries, I1 and I2, and here there are some values given us. Now we will explain each value here. This first value here, that means $10 million value of output of industry 1 is consumed by industry 1 itself. Similarly, $25 million dollars value of output of industry 1 is consumed by industry 2. Similarly, here this signifies the $20 million dollars value of output of industry 2 is consumed by industry 1, and similarly this is the self consumption, that is $30 million of value of output of industry 2 is consumed by industry 2 itself. So this is the internal consumption. And also we are given here the final demands, that is $15 million of output of industry first. Similarly, $10 million of output of the industry second. And in the last column we are given the addition of these internal demands and the final demand, that is 10 plus 20 plus 15, which is equal to 50, and 20 plus 30 plus 10, which is equal to 60. Now the question says determine the output levels when the final demand changes from 35 for I1, sorry, it is here I1, and 40 for I2. We have to see what output levels should the industries produce if the final demand changes from 35 for industry first, this very column, and 42 for industry second. So this is our question. Now we will start solving this question. First of all, we will write these values by, I will write A11 is equal to 10 here. So this A11 is simply the $10 million value of output of industry first, which is consumed by industry first itself. Similarly, we have A12, which is this very number, that is 25, and A21 is this 20, and A22 is 30. I have already explained this in the earlier video. Now here this A12 means this very, which I have explained earlier. This A12 means the $25 million value of output of industry 1 is consumed by industry 2. So this is $25 million here. Also we are given x1, which is the gross output, is 50, and x2 is given us which is 60. Now we will write another number, that is here another expression, that is B11 is equal to A11 divided by x1. Now what does this mean? This simply means that this B11 simply means the dollars value of input, from industry first required to produce $1 worth of output of industry first itself, that is the self consumption. So here it comes out to be 10 divided by 50, which is equal to 1 divided by 5. Now similarly we have B12 we have B12 which is equal to A12 divided by x2. Now what does this mean here? This simply means that dollars value of input from industry 1 required to produce $1 worth of output of industry 2, which is equal to here A12 is given, that's 25, so I will write here 25 divided by x2. So our x2 is 60, so I will write here 60. This comes out to be that is 5 5s are 5 12s are, so this is 5 divided by 12. Similarly we can write others, that is B21 is equal to A21 divided by x1. Our A21 is, while that is 20, our x1 is 50, which is 2 by 5 here, 2 by 5. Similarly we have B22 which is A22 divided by x2, that is equal to now our A22 is 30 divided by 60, which comes out to be 31s are 32s are, so this is 1 divided by 2. Okay, now this is our technological matrix also. So our technological matrix, which is denoted by B, is, so our technological matrix is B, which is equal to so I will write here B11, B12, B21 and B22. Now we give the values of each parameter. Here B11 is 1 divided by 5, 1 divided by 5. B12 is 5 divided by 12, 5 divided by 12. Similarly B21 is 2 divided by 5 and B22 is 1 divided by 2. So this is our technological matrix. Now we will form the Leontief matrix. So forming Leontief matrix is very easy. What we will do, we will subtract from an identity matrix the technological matrix, that is I minus B. Here I is the identity matrix and this is the technological matrix. So I minus B is equal to, I will write here, that is 1 0 0 1. From that we subtract this B, this technological matrix, which is 1 divided by 5, 5 divided by 12, 2 divided by 5 and 1 divided by 2, which comes out to be now 1 minus 1 divided by 5, that is 1 minus 1 divided by 5, which is 4 divided by 5. So I will write 4 divided by 5. Similarly 0 minus 5 divided by 12, that is minus 5 divided by 12. Similarly 0 minus, so this is minus 2 divided by 5. Now 1 minus 1 by 2, that is 1 divided by 2. So our I minus B, which is the Leontief matrix, I will write here, this I minus B is called Leontief matrix, which is formed by subtracting the technology matrix from the identity matrix. Now after that we have to see the Hawking-Simon conditions to be sure that the problem has a solution or not. Here the first condition was that the principal elements, that is the elements on the principal diagonal, should be positive. This very diagonal is called principal diagonal. So here we can see that all the elements are positive. So first condition is met. Here we can see first condition was that elements on principal diagonal should be positive. Here this 4 by 5 is positive, 1 by 2 is positive, so first condition is met. Now second condition says that the determinant of this Leontief matrix should be greater than 0. So we will take the determinant of this Leontief matrix, that is we will write I minus b. That means determinant of this Leontief matrix, which is equal to, now determinant is simply we multiply the elements on the principal diagonal, that is 4 by 5 and 1 by 2, and from there we subtract the product of the non-principal diagonals. So this is here minus 2 by 5 times minus 5 by 12. Now here we can see this is 4 ones are 4 divided by 5 twos are 10 minus, now minus into minus is plus 2, 5 twos are 10, 5 12s are 60. That comes out to be here, that comes out to be 5 twos are 10, so I will write here 10, and 12 fives are 60, that is 60. When solving, this comes out to be so here it is 1 by 6. Now multiplying, that is 4 6 are 24, 24 minus 10 ones are 10 divided by 10 6 are 60, so this is here 14 divided by 60. Now 2 7s are and 2 30s are, so I minus b will come out to be, so here it is 7 by 30 is equal to 7 by 30, which is greater than 0, i.e. it is positive. So second condition is also met, that is the determinant of this Leontief matrix should be positive, which comes out to be positive in this case. Now since both the conditions are satisfied, we can say that Hawking-Simon conditions are satisfied, implies the problem has the solution. Problem has the, now here the Hawking-Simon conditions are satisfied, that is the elements on the principal diagonal of a Leontief matrix should be positive. We see here these are positive. And second condition was that the determinant of the Leontief matrix should be greater than 0 or positive. So both the conditions are satisfied, so we are also satisfied the problem has the solution. Now coming to the solution part. Now I should take a deep breath because it's very chilly here in our part of area. It feels that the cold has reached to its maximum today. Now we have to find the solution. So we are with this Leontief matrix. So I will write here again I minus b is equal to 4 divided by 5 minus 5 by 12 minus 2 by 5 and 1 by 2. So this is our Leontief matrix. First of all we have to find the adjoint of this Leontief matrix. Now adjoint is given by adjoint of I minus b is given by, which is very simple. What will we do in case of 2 by 2 matrix? we interchange the principal diagonal elements, that is 1 by 2 will come at this point, at this place 4 by 5, so we will interchange these two. So 1 by 2 will be at this place and 4 by 5 will be at this place. Simply we interchange these two elements, and we change the signs of other elements. So if it is minus, it will become plus, and if it is minus, it will become plus. So this is 5 by 12 and 2 by 5. So it's to be remembered here, we interchange the elements on the principal diagonal, and we change only the signs of the other elements. We don't interchange the elements itself. So this is our adjoint matrix. So this this trick comes out handy for 2 by 2 matrix. If it were the 3 by 3 matrix, then we have to go by the usual method of finding the adjoint. Okay, I hope I am making myself clear. Now inverse of this, so I will write inverse is given by I minus b inverse. Actually, I will write here what we have to do. We have to find, we have shown this relation x is equal to I minus b inverse times the new final demand. So we have to form this this very relation. For that we need first of all the Leontief matrix, which is here, and then we have to take the inverse of this. For inverse we need the adjoint, and for this very relation we will take the inverse. Now inverse is simply 1 divided by the determinant of I minus b Leontief matrix times adjoint of I minus b. Now here we can see, so I will write here our determinant was somewhere, we have calculated the determinant, that is 7 by 13. So I will write 1 divided by 7 by 30 times the adjoint. So we have got this adjoint, that's 1 by 2, 5 by 12, 2 by 5 and 4 by 5. Now doing the usual calculation, this will reciprocate, so this will become 30 divided by 7, 30 divided by 7, and this is 1 by 2, 5 by 12, 2 by 5 and 4 by 5. Now giving the values here, actually I have calculated this very calculation, so I will write here. So this is 31s are, that is 30 divided by 7 2s are 14. So I will write similarly here 30 into 5, that is 150, 150 divided by 84. So I will write here it is 60 divided by 35, and it is 120 divided by 35. So this is our inverse here. Now we have the relation. Relation is x is equal to I minus b inverse times the new demand, which has changed, that is 35 and 42, times d. So I will write here where d is, so I will write here d is 35 and 42. So I will write 35 and 42. This is the new column vector here. Now because of the lack of the space, I will take another sheet. Don't worry, I will take another sheet. Okay, now our x is equal to I minus b inverse. I minus b inverse we have calculated. This is this very matrix, which is 30 by 12, 30 by 14, sorry, 150 divided by 84. We have 60 by 35, 60 by 35, and 120 divided by 35. So this is our I minus B inverse times D. Our D is 35 and 42. So I will write 35 and 42. Now we have to multiply these two matrices. Now multiplication is very easy. We multiply rows and column, first row and first column. That is, our x will be equal to, that is 30 divided by 14, first row, this very times 35 plus 150 divided by 84 times 42. That is this element times this element plus this element times this element. Similarly, we have 60 divided by 35. Actually, I have shown this whole stuff in earlier videos, how we multiply the two matrices. Times 35 times 35 plus 120 divided by 35 times 42. Now when solving this, actually I have calculated this very stuff. This comes out to be 150 divided by 204. That means our x is equal to x1 new, x2 new. Our new output level will be 150 and $204 million. That means, that is to say, the output of industry I1 should be 150 million dollars, and for I2 should be $204 million. So this was a simple question on the applications of input output analysis in economics. I hope you enjoy the video. If you really enjoyed, please subscribe and share. Thank you.